In this video, we will see code implementation. Now let's quickly check the code implementation of cycle detection in a directed graph. So I have V, I have adjacency list. So V as vertices and adjacency list. So what I will do, I will create my basically visited array, that is new array of V size dot it will false. Same will go with the path visited. So I will say this be my path, okay, with false, and I will simply start I equals to 0, I less than v, I plus plus. Now what I will do, I will check if I have not visited it. If I have not visited any of the Cincy list, what I will do, I will call my DFS function. DFS with I this path and adjacency list as in parameter. And if it is returning true, I will simply return true. And if suppose I was not able to find out any solution, I will return false. That's it. False. Okay. Now after this, what I will do now, the only task is left is to create a DFS function. So I will create a DFS function DFS with node, with visited, path visited, with adjacency list. Okay. Now what I will do, I will simply check if visited node is equals to true. I will make this true. If visited node is equals to true, I will make not visited, sorry, path visited. Both the path visited equals to true. Once this is done, what I will do again, I will call for the neighbors. So let neighbor of my adjacency node. Okay, this I will do, and I will check if suppose DFS of node, basically neighbor, sorry, no, that is neighbor visited array, then path visited array, then adjacency list. Okay, if this is true, again return true. So I will return true. Okay. Once suppose before calling this one, right? Before calling this one, I should call first if I have visited or not. So I will call if not visited, then only call I need to do this thing. So if visited of neighbor. If I have not visited neighbor, then I will call this function. So this should become this. Okay. Else, there is one possibility you have already visited. Then I will check else if condition. Then I will check if I have a path visited or not. So I will check if path is also visited. Path is also true. Okay. So if that is true, but I will check of true this neighbor, right? If path of neighbor, else if condition is path of neighbor is also true, then what I will do, I will say that this is in the same path, I will return true, right? Else, right? Now if condition, else what I will do, I will simply go on, right? Simply do the remaining things. And now what I will do after this for loop, okay, what I will do, I will say now I am returning from it. So I will say path of node equals to make it false, and I will say return false. Okay. So this will be my DFS function. Again, let's see. Basically, when I am coming to a different DFS function, I will visit the node, make it true. I will visit the path, I will make it true. And then I will check the neighbor of my adjacency node. So whatever the neighbor is, I will check if it is not visited, then if it is not visited, and then I need to call the DFS function. Okay. And if I'm calling DFS function, if it is returning me true, that it is a cycle, I will return true. Okay. If suppose I have already visited, then I will check if path is also visited. Yes, path is also visited, then I will return true. That's the condition of true. Okay. If it is not visited, then what I will do, I will check for the other neighbors, right? Other neighbors. And after the for loop, suppose this DFS is done, I will return. So basically before returning, I will make that path node equals to false and I will return. So this is the code implementation of a cyclic. Okay. Now in the next video, we will check out the code dry run of it, basically how this all things is working. Okay. It won't take too much time. Okay. But we will get how basically this code is working. So see you in the next video.